Hey guys, Sneaky Kitty Game Dev here, and in this video what we're going to be doing is talking about templates. So kind of, I guess you could say more or less, how and why you would actually use them. So for this example, what I'm going to do is we're going to have a simple function that is going to take in two parameters, a and b, add them together, and return the result. So to do that, let's just start out very simple. We're going to write this out, and it's going to be of the type float. For everything I have here, you can ignore, and down here you can ignore. This is for a example coming shortly. So we're just going to do with floats. So float, add together, and we're going to take in a float A and a float B. So we just want to add these two together and return it. So we're going to return A plus B. Simple enough. Now we're going to print this out. So let's see out, add together, and we're going to do 5.5 and 6.2. Simple enough. So let's run this, and we should get our result of 11 something. So, yep, 5 plus 5, or 5.5 plus 6.2 is 11.7. So that's correct. Now, let's say we have our own custom data type, or want to do an integer. Well, integer is pretty simple. The output stream will kind of take care of this for us, but it's still, the end result is going to actually be a floating point. So, yeah, it works. And we can also, well, we really want to have the end or the return result be of a type we specify. And this is especially true if we have custom types where we can't necessarily do, a plus b, or we're going to have to write another function. So this works fine for, floats, and you can technically make use of it with other types like integers and such. But let's say we have our own custom type right here. So I want to add two of these types together. So I've already overloaded the plus operator as well as the output stream so we can have, print the result. Let's go ahead and just see how we could do that. So I want to copy here and just move this on back up like so. And I want to add together type 1 and type 2. So as you can see, it's complaining because we cannot convert from my type to a float. So even though we've overloaded the plus operator, or addition, whatever you want to call it, it's still not going to work. However, I don't also want to have to, duplicate the function only to literally do this. So actually, yeah, that'll work with the same name. I don't want to have to do that to have multiple functions for different types. So for example, this prints out what it's set to print out in the output stream, so that all works correctly. So how can we do that? Well, that's where templates come into play. So for example, we're going to leave this as is, and we're going to start changing it out to be a templated function. So to do that, we just type in template, and then you can do class. I'm going to name mine type. This is commonly also associated with T. And I'm going to replace float with T, like so. And as you can see, the complaint went away. So let's give this a try. So we printed out age and our time and our age. That all worked, and we can also change this to be back at 5.5 and 6.2, I think it was. And this should also work. And same thing goes with other types like integers. And we can also make this work with doubles, unsigned, and all that kind of stuff. It'll just basically whatever type we pass in, as long as it overloads the addition or plus operator, you're going to be good to go. So you can add the types that way, all from a single function, instead of having to have multiple functions that do basically the same thing. So that's just one example of templates. Now I have another one that I wrote in preparation for this down here. Let me copy and bring all this back up. Okay, so what this is this is kind of a, I should say a semi-common use case. This is something that I'll do regularly in Unreal Engine. So I have my base class here called item. It contains nothing, just a virtual destructor. That's just so I can dynamic cast. And then we have a second class which inherits from item, and a third class which inherits from item. And then we just have a simple class called inventory. And this inventory simply holds a pointer of the type item. So that item could be the apple, orange, or any other class. including that is also derived from item. So, what is an example of a use case here? Well, one would be, getting the inventory. So let's first off create our inventory. So inventory, my inventory equals new inventory. And I'm going to do my inventory set item. I need to actually create an item that we're going to use first. So let's just do, let's see. We're going to do an apple first. So apple, my fruit, or my item equals new apple. And we're just going to pass in my item to set item. So this variable here, inventory item, is now going to be of the type apple. However, you can see the type is set as item. So basically, what I want to do is, let's say we have a specific function on apple that we want to call that's not a part of item. Well, let's go ahead and create one. So we're going to make a public section. And I'm just going to do, let's do float apple variable, get apple variable. Can't really think of any other name. And we're just going to simply return 10. Simple enough. So let's say I want to print out the result of this function that is only inside of apple. So std cout. Let's just do my inventory, get item, and we'll end the line. So currently the way you would use the template is pretty standard. So in my case, it's by default, it's going to be of item. So we can get the item, and we don't have that function. We don't have any function other than the destructor. But if I convert this from item to apple, you can see now I have get apple variable. So I have that function. So in theory, this is actually going to work. This will return 10, like so. But you also run into some issues of what if it's not of the type apple? So what if I did orange? And then I try to run this. Well, as you can see, nothing's complaining. The compiler's not going to complain. But when I run it, why the heck are you showing 10? You should not be casting to apple at all. Unless it's, unless that's a fluke here. All right, so it's basically how I was handling it. That was the cause. So basically, if I replace it and I add a, let's do float, my apple variable, and I'll set that equal to 10, and we return that instead. Now we should start seeing it. So if I press F5 to launch with a debugger, you can see it throws an exception because this is a null pointer. So we're basically accessing nothing. But if I change this from type of orange to type of apple, and then run it, press F5, you can see we print out 10. So you can see the cast was invalid in the previous run, but valid in this run. So that's because we're casting to a specific type. If the type fails, then we can't do anything with it. So here's where you would commonly wrap it. So for example, we can leave all this up here. So if apple, my apple equals, and from here we can do inventory, or my inventory, get item of the type apple, then we know we have our apple. So we can do this right here directly off of apple. And then otherwise, print out failed to get item of type. So now if we run it, this will still be good to go. We print out 10 because that's the apple variable. Now, if we have this of a different type, such as, the default item, failed to get item of type. Same thing if we do of a child class, such as orange. Oops. Then we get the same thing, failed to get item of type. So basically, this is like I guess you could say a cleaner way of doing the cast yourself everywhere. So for example, I have a firearm system, an attachment system with that, and basically all my parts, like firearm attachments, derive from a base class. And the way I handle a lot of this stuff is I will simply have a getter function to get a part of a specific type. So I can cast to that type, so that way I don't have to get the part and then cast to it. Because if I didn't have to do, or if I didn't have that, basically I would be doing a dynamic cast anywhere I had it. So for example, I would have to get the item, see if that item is even valid, and go from there. So I guess even in here we should be doing that check as well. But so in here I'll basically be getting the item. So let me make this no longer a template, and that's going to be of the type item. Just like so, all we do is return inventory item. Here you can see this is no longer working, it's throwing a fit. So we can get the item, but we have to do a dynamic cast to a specific type of our choice, such as apple, every single time that we wanted to go through and actually, make use of our inventory item. And syntax incorrect, but you can kind of imagine that would get kind of old and annoying, but it's just a more cleaner way of handling things, I guess you could say. So again, it kind of depends on you. But there's two kind of general use cases of that I commonly use to do this stuff with. So I'll do this a lot with custom structures. So that way if I have a function that I need to handle anything with, I can do that. So I can make it work with a couple different types if I need to, as well as commonly a bunch of getter functions where I would have one parent class with a couple children classes with different information that I might need to access. But I don't want to at the same time have to get it and then cast it, when instead I can just get access to whatever container is holding them and just cast it directly when I go to get it. So that way I can just keep all that logic contained in a single place. I'm writing less code, I'm reusing more of it. And anywhere that I need to change how I'm handling it, I can do so in one place. So that's kind of the gist of templates. It's basically a way to have, you can literally kind of think of it as the name, template, to have a single function that can handle multiple roles. I guess that's kind of a way to put it. So you can treat it for multiple different types. So you're not just locked down to doing it with a float or a string or some other type like that. You can have it set up to be used with basically any type you want. Now, that's going to wrap up this video. Hopefully you enjoyed it and it taught you something. I felt like I was rambling a good bit at the end there, but hopefully it gets the point across. So I'll see you in the next video.